Welcome back to Max with RP. We will continue with word problems involving maxima and minima. This is the first problem we are going to discuss. Show that the semi-vertical angle of a right circular cone of given surface area and maximum volume is sine inverse 1 by 3. So this is a cone. Let this be the height and let this be the radius. R and height, and this is theta. Okay. So what is given? Surface area. Unless and until it is mentioned, if they say surface area, it means total surface area. Okay. So this is L. So what will be the surface area? Pi r L plus pi r square. S equal to pi r L plus pi r square. Okay. Now what is it that you have to maximize? There can be several such cones with this parameter with a given surface area, but we want to find that one which has got maximum volume. So we have to maximize the volume. Maximize volume. What is volume? 1 by 3 pi r square h. Okay. Now V square equal to 1 by 9 pi square r power 4 h square. So we have to substitute for h square, but we only know from here what it implies. L equal to s minus pi r square by pi r, and we also know L square equal to h square plus r square, or h square equal to L square minus r square. Okay, but L is this, where L is this. Okay, so this is very important. So V square is 1 by 9 pi square r power 4 h square, which is L square minus r square. L square is what? S minus pi r square by pi r, the whole square. This is L square. So h square is what? L square minus r square. When I do this, I have reduced the entire function as a function of a single variable r. Otherwise, here both r and h are variables. Okay, so now finally it boils down to simplification, calculation, etc. So this V square, let me call it as f of x, is equal to, okay, 1 by 9. In fact, I can take 9 times f of x is 9 times V square as f of x. If V square is maximum, 9 V square is also maximum. So that I am calling it as f of x equal to pi square r power 4, right, into, I'll take the LCM as pi square r square. Pi square r square. Then what will I get? S square plus pi square r power 4. I am squaring this, minus 2s pi r square, minus, when I take LCM, what will be? This will be pi square r power 4. Pi square r power 4, which gets cancelled. So this is pi square r power 4 by pi square r square into s square minus 2s pi r square. Okay, see, listen, I am not even differentiated, I am only simplifying. So here you remember this becomes on squaring pi square r square. So when I take pi square r square as LCM, this will become pi square r power 4. So pi square r power 4 gets cancelled, giving you s square minus 2s pi r square. Now here pi square gets cancelled, 1 r square gets cancelled, giving you r square. So this is s r square minus 2s pi r power 4. Because here is 1 r square, here is 1 r square. This is your f. Now df by dr will be equal to s into 2r minus 2s pi is a constant. Derivative of r power 4 is 4r cube. Equate it to 0 to find the critical point. Okay, so this will 2sr will give you what? 4 into 2, 8 pi s r cube. So cancel off 1 r, this becomes r square. Cancel off 1 2, this becomes 4. Somewhere I have missed s square. So this will be s square into 2r. So this will be s square. So 1 s gets cancelled, giving you s is equal to 4 pi r square. So the critical point is obtained when s is equal to 4 pi r square. Okay. Now when s is 4 pi r square, what will be L? L will be 3. I'm substituting in 1. Substituting in 1. You will get 4 pi r square minus pi r square is 3 pi r square by pi r. So L equal to 3r. Okay. Now sin theta equal to r by L. So r by 3r, which is 1 by 3, which implies theta equal to sin inverse 1 by 3, which is what we are expecting to prove. The maximum volume occurs at s equal to 4 pi r square. When s is 4 pi r square, theta is sin inverse 1 by 3. So what is the conclusion test remaining? Second derivative test. So I'll do here second derivative test. Df by dr is this. So d square f by dr square will be equal to, when I differentiate this, what will I get? 2s square minus, when I differentiate this one, what will I get? 8 pi, okay, 8 pi s r cube. This is what? So when I differentiate, what will I get? 8 pi 3r square. 2 pi s into 12 r, 2 pi s. I will differentiate this, 2 pi s minus 2 pi s into, differentiate 4r cube. 4 into r cube, if I differentiate 3r square. So 2 into s square, 2s square minus, this will be what? 4 into 2, 8, 8 into 3, 12, pi into 4 pi r square into r square. S is 4 pi r square into r square. You can see that it is less than 0. Substitute s also here as 4 pi r square. Then you can see it is less than 0. Therefore, the surface volume is maximum at sin theta equal to 1 by 3. Is it clear? Now a wire of length 20 meters is cut into two pieces. Okay. So if this is x, this will be 20 minus x. One is bent to form a square. The other is bent to form an equilateral triangle. So you bend this x and make a square. You bend this portion of the wire and make an equilateral triangle. So this is a square. Let us suppose the side is A. This is an equilateral triangle. Let us suppose the side is B. Now we have to, the question is, what should be the length of the two pieces? Where should you cut so that the combined area is minimum? Combined area means what? Combined area of the square and the equilateral triangle. So combined area is equal to what? Area of the square, which is A square, area of the equilateral triangle, which is root 3 by 4 B square. It's a function of A and B, so A and B are variables. Okay, but we know x is made into how many A's? 4A. Because this is x is what is bent into a square. The side of the square is A. So 4A is the perimeter of the square, right? So x is 4A. So A will be x by 4. So I can write A in terms of x. Similarly, 20 minus x is bent into 3 times B. That is made into the equilateral triangle. So the perimeter of the equilateral triangle is 20 minus x. So B equal to 20 minus x by 3. Okay. So substituting here, A square will be x square by 16 plus root 3 by 4 combined area into B square, which is 20 minus x the whole square by 9. So this is x square by 16 plus root 3 by 36 into 20 minus x the whole square. So if it has to be, the combined area has to be minimum, we have to find the critical point. So dA by dx is equal to 0. So 2x by 16 plus root 3 by 36, 2 into 20 minus x into minus 1 equal to 0. Derivative of 20 minus x the whole square is 2 into 20 minus x into minus 1. This is root 3 by 36. Now to find the critical point, this is x by 8. X by 8 is equal to, because I have a minus sign, I can just take it to the other side, root 3 by 18, because 18 into 2 is 36 into 20 minus x. Okay, so this is 20 into root 3 by 18 minus root 3 by 18 into x. Equal to x by 8. So x plus x into x 1 by 8 plus root 3 by 18 equal to 20 root 3 by 18. So x will be, so I will take, what is the 8 and 18? So I will take LCM as what? 8. 18 plus 8 root 3 into 18 into 8. 144. equal to, this is x is equal to x into this equal to 20 root 3 by 18. See, x by 8 is 20 root 3 by 18 minus root 3 18 by x. So, x into 1 by 8 plus root 3 by 18 equal to 20 root 3 by 18. Okay. So, x into 18 plus 8 root 3 by 144 is this. So, x will be what? 20 root 3 by 18 into 144 by 18 plus 8 root 3. So, 18 goes on by 8 times, we know. So, x is equal to 20 root 3 into 8. So, 160 root 3 by 18 plus 8 root 3. What should be the length of the other part? So, find x. Please find 20 minus x. This is x. Okay, if you want, you can use 1.732 for root 3 and simplify, or you can keep it as it is. Also find 20 minus x to find the other part. What should be the length of the two pieces? So, if this is one piece, what is the other piece? Okay, now we have to find d square a by dx square. Now, d square a by dx square will be, if I simply differentiate this, I will get 1 by 8, right? Sorry, 2x by 16. I've already differentiated here. So, x by 8. So, 1 by 8. Then when I simplify this, what will I get? The constant will become 0. So, what will be here? Minus into minus will be plus. What is the coefficient of x? 2 root 3 by 36. Root 3 by 36 into 2. As you can see, it is greater than 0. Therefore, the combined area is minimum. Are you able to follow? So, for lack of space, I have not found 20 minus x. I am sure you can take LCM and find 20 minus x. I hope you understood how to proceed when you are given a problem of this sort. Next question, the sum of the perimeters of a circle and a square is k, where k is some constant. Prove that the sum of their areas is least when the side of the square is equal to the diameter of the circle. So, what is k? Perimeter of a circle is what? 2 pi r. Let r be the radius of the circle. Plus, for a square, let a be the side of the square. Then 2 pi r plus 4a is a constant. Okay. Now, this is given. You have to prove sum of their areas is least. Minimize sum of their areas, which is pi r square plus a square. So, here both a and r are variables. Okay. Now, from here, you can write, see, if 2 pi r plus 4a equal to k. So, I can write 4a equal to k minus 2 pi r, or a equal to k minus 2 pi r by 4. So, we have to minimize area, which is equal to pi r square plus a square, where the relationship between a and r is given here. Okay. Now, a is equal to pi r square plus a square, which is 1 by 16 into k minus 2 pi r the whole square. This is pi r square plus 1 by 16 into k square plus 4 pi r square minus 4 k pi r. Pi r square plus k minus 2 pi r by 4 the whole square. So 1 by 16 into k square plus 4 pi square r square minus 2k into 2 pi r. 2k into 2 pi r is 4k pi r. Okay. Now this is A. So dA by dr will be pi into 2r. K square by 16 it will be 0 plus 4 pi r square by 16 into 2r. Okay. Minus 4k pi equal to 0. To find the critical point, I am differentiating with respect to r. So the derivative of r square is 2r. Derivative of k square by 16 is 0. Derivative of 4 pi r square is a constant, but r square is a variable, 2r by 16. 4 pi r square into 2r by 16 minus 4k by 16. Minus 4k pi by 16 is a coefficient of r. Okay. So this is equal to 0. Therefore, I can cancel off 1, 2 everywhere. So I will get pi r plus 1, 2 I am cancelling 4 pi square r by 16 because I am cancelling off 1, 2. So pi square r by 16 is equal to, I am cancelling 1, 2, 2k pi by 16. Okay. So what do you get? Can I cancel off 1 pi? So r plus pi r by 4. Pi, 1 pi I am going to cancel off everywhere. So I will be left with r. 1 pi is here, pi r by 4 is equal to pi I have cancelled. So k by 8. So taking LCM, 4 r plus pi r by 4 equal to k by 8. So 8r plus 2 pi r equal to k. But what is k? 2 pi r plus 4a. This is equal to 2 pi r plus 4a. So 2 pi r gets cancelled. So 8r equal to 4a or 2r equal to a. That's what you have to prove. That is, side of the square is equal to diameter of the circle. This is side of the square. This is diameter of the circle. So proved. We have proved a equal to 2r. So what is left? Only second derivative. D square a by dr square will be, when I differentiate this, I will get 2 pi. Okay, when I differentiate this, I will get 4 pi square by 16. Pi square by 4. 4 into 2, 8 by 16. So I will get pi square by 2 into derivative of 2r will be 2 minus, if I differentiate this is a constant, it will be 0. So you can see that it is, see here you have to prove the sum of the areas is least. So second derivative is positive. If you want, you can check. The derivative is 2 pi. Here when I differentiate, I get 2 into 8. 8 by 16 is pi by 2. Pi square by 2 r into 2r. If I differentiate, I will get only 2. So sorry, I have already used 2. So pi square by 2. Because 4 goes in 16 4 times, 2 goes 2 times. So pi square by 2. When I differentiate this is a constant. So it will be 0. So you can clearly see it is a positive quantity. Therefore, sum of the areas is least when the side of the square, which is a, is equal to 2r, which is the diameter of the circle. I hope you benefited by going along with me how to solve these three problems that we did today in this video. And if you find this useful, please you practice it again and again, and also share the video with your friends. And please go through the sequence of videos. I intend to cover all kinds of problems that's going to be asked in maxima and minima, which is a very, very important chapter. All the best for your upcoming exams. Until we meet next time, it's goodbye.